Dear students, welcome to Eazy Btech, your guide for Btech and beyond. Here we are going to discuss signals and systems subject, and topic is classification of signals. Very important topic. We will see topic now. Before going to our topic, subscribe, share the channel. Let's start our session. Classification of signals. Classification of signals. In the previous session, we discussed classification of signals. We discussed continuous time and discrete time signals, even and odd signals, periodic and aperiodic signals. Okay, now I am going to tell one point about periodic and aperiodic signals. For example, x of t is like combination of x1 of t, x2 of t. If the signal is like this, x1 of t plus x2 of t. Now, to check the given signal, means x of t is periodic or not. Is it periodic or not? If it is periodic, what is the time period? What is the time period? So how to do this type of problem or this type of signal, how to do time period? So the procedure is very simple. First we see the time period of x1. That time period is t1, and the time period of x2, it is t2. Separately we do x1 time period, x2 time period, t1, t2. After doing t1 and t2, do this ratio t1 by t2. t1 by t2. If you get t1 by t2 is rational number, it is rational number, then the given signal is periodic. If t1 by t2 is rational number, then x of t is periodic. Very simple. X of t is periodic. After knowing periodic, then we need to say what is the time period of this x of t. So time period capital T is equal to LCM of t1, t2. LCM of t1, t2. LCM we need to do. t1, t2 LCM, which will be the time period of the x of t. In the same fashion, in the same way, if x of n, discrete time signal I am taking now. If x of n is combination of x1 of n plus x2 of n, then calculate x1 of n time period and take it as n1. Calculate x2 of n time period, take it as n2. After doing n1 and n2, do the ratio n1 by n2. If n1 by n2 is rational, it is rational number, then the given signal is periodic. The given signal is periodic. What is the time period? The time period capital N is equal to LCM of n1, n2. LCM of n1, n2. So this is the way we do time period of x of t, time period of x of n. Right? Now we will see the example, the simple example. Let's take x of t is equal to, take x of t is equal to sine pi by 4n. Sorry, it is a continuous time signal. So sine pi by 4t sine pi by 4t plus cos pi by 3t. So the question is, x of t is periodic or not? This x of t is periodic or not? If periodic, what is the time period? Periodic or not? And what is the time period? Simple. First we need to do individual time period. Individual time period. Sine pi by 4t. What is the time period? t1 is equal to 2 pi by omega naught. This is omega naught. So 2 pi by omega naught, which will be 2 pi by 4 is equal to 8. Right? Pi get cancelled, 8 we get. Similarly, for cos pi by 3t, what is the time period? Same, 2 pi by omega naught. Here, omega naught is how much? Pi by 3. So this will become 2 pi by 3 is equal to 6. After doing t1 and t2, do the ratio t1 by t2. What is the ratio now? t1 is 8, t2 is 6. This can be 4 by 3. So 4 by 3 is the rational number. Rational number means ratio of two integers. Ratio of integers. 4 is integer, 3 is integer. That is why rational number. Rational number means what? What is the clarity? The given x of t or given signal is periodic signal. Given signal is periodic signal. Periodic signal. Then how to do LCM? Sorry, total time period t is equal to what? LCM of t1 and t2. t1, t2 LCM. So what is the LCM of 8 and 6? t1 is 8 and t2 is 6. What is the LCM? What is the LCM? Here I am doing roughly 2 4 jar, 2 3 jar. So 4 into 2, 8, 8 into 3, 24 is the time period. 24 seconds. This is the way. Right? Very simple. This type of problem. Now, similarly, I am taking discrete time signal, the same signal but discrete time. That means x of n equal to sine pi by 4n plus cos pi by 3n. The same problem but discrete time, n, small n. So what is the time period of this first one? It is n1, which will be 2 pi by omega naught. What is omega naught here? Pi by 4. So we can take small m also. 2 pi by 4. Pi get cancelled. We have 8m. So m can be any integer, like m is equal to 1, 2, 3. We can take 1, 2, 3 and so on. Minimum value of m. So that total n value will become integer. So what is the minimum value of m we take? 1 is enough. So n1 is 8. Next n2. So n2 is also same way. 2 pi by omega naught into m. Here omega naught is pi by 3. Right? So n2 is equal to 2 pi divided by pi by 3 into m. It will be 6m. So we can take m is 1. The m value we can take 1. Then it will be 6. Now after doing n1 and n2, do the ratio n1 n2 ratio 8 by 6, again 4 by 3. So 4 by 3 is the rational number. right or not? Rational number. Therefore, the given signal is periodic. That is a clarity because we got rational number. So given signal is periodic. The given signal is periodic. What is a period? Period n equal LCM of n1 n2. n1 n2 LCM. So is equal LCM of 8 6. How much? 24. So same time period we have. So this is the way of doing whenever the signal x of n is combination of x1 x2, right? Next we are going to see another classification, energy and power signals. Energy and power signals. Energy and power signals. First I am talking power of a signal. How to define power of a signal. So let's take the continuous time signal x of t. Consider x of t is continuous time signal. The average power of x of t is defined as average power of x of t is defined as so p average is equal limit capital T tends to infinity 1 by 2t integral minus t2 plus t mod x of t whole square dt. Mod x of t square dt. So this is the average power of a signal x of t. So generally power units watts. Now in the same way we can define energy of signal continuous time signal x of t. So x of t is again I am taking continuous time signal. Energy is defined as energy of x of t. Whose energy? X of t energy. So energy of x of t is defined as E is equal energy is equal limit t tends to infinity integral minus t2 plus t mod x of t whole square dt. Mod x of t whole square dt. Here 2t, the duration minus t2 plus t. What is the duration here? 2t is the duration. Duration is 2t. Right? So we are dividing this x of t square integral minus t2 plus t. This is divided by 2t by the duration. Then we get average power dividing by 2t. So here minus t2 plus t limit t tends to infinity mod x of t whole square dt. Or you can write in this manner. I am keeping limit now t tends to infinity minus infinite plus infinite mod x of t whole square dt. Both are same. So generally joules, units of energy, joules. Okay. Average power and energy of the continuous time signal x of t. Right. Now the signal, I am telling now definition. Power signal. What is a power signal? The signal is said to be power signal if its power is finite and energy is infinite. For power signal, the simple definition for power signal, power is finite, energy is infinite. Power is finite and energy is infinite. Then that signal is called power signal. Come to energy signal. For energy signal, if you take energy signal, our signal is said to be energy signal. If energy is finite, energy value finite, and power is 0. The power is 0. Then it will become energy signal. Okay. So this is the way of doing power calculation, way of energy calculation. Then the signal, power signal definition, power is finite, energy is infinite. Energy signal definition, energy is finite, power is 0. In the same fashion, we can do for discrete time signals also. For discrete time signal, x of n is a discrete time signal. So what is the average power? P average is equal to limit capital N tends to infinity 1 by 2n plus 1. This is duration. 2n plus 1 is the duration. Summation minus n2 plus n mod x of n whole square. Here we have summation, not integration, because discrete time signal. Similarly, energy is equal to limit n tends to infinity summation n is minus n2 plus n mod x of n whole square, mod x of n whole square. Or you can write like this sentence to infinity we can keep. So summation minus infinite to plus infinite mod x of n whole square. This is a way of doing energy calculation and power calculation. So here one point I can tell, a signal can be neither energy nor power. Neither energy nor power signal. The signal can be neither energy nor power signal. Nor power signal. The example for this case is ramp signal. Ramp is not energy signal, not power signal. Ramp is not energy signal, not power signal. And continuous time impulse function, del of t also not energy signal, not power signal. Okay. So this is the point. Now, I will give you some formulas. If you have summation n is 0 to infinity c power n, infinite summation 0 to infinity c power n. So this total value 1 by 1 minus c. If c is less than 1, mod c is less than 1, then only 1 by 1 minus c. Okay, otherwise infinity you get. And the second one, summation n is 0 to n minus 1, capital N minus 1, c power n. This value 1 minus c power n by 1 minus c. And here the c value is not equal to 1. C is not equal to 1. And the third thing, summation n is equal to 0 to n minus 1, 1. Here 1. So this total is n you get. Or this we can write like this. Summation n is equal to 0 to n 1. 0 to n 1. This answer is n plus 1. Here n, because 0 to n minus 1. Here 0 to n, that is why n plus 1. You can write in this also. Summation n is equal 0 to 2n 1. 0 to 2n 1. It will become 2n plus 1. The same manner here n, upper limit is n, that is why n plus 1. Here upper limit is 2n, that is why 2n plus n. So these formulas are helpful to you whenever we are going to do problems. Okay. Now let's have some problems on energy and power. So first we do power calculation. How to do power? So take an example. X of t is equal to a cos omega naught t. What is the power of this signal? So we have a formula, power is equal to average power. What is the power formula? Limit t tends to infinity 1 by 2t integral minus t2 plus t mod x of t whole square dt. So here given signal is a cos 2t, sorry, a cos omega naught t. So take that in the place of x of t whole square. Limit minus t2 plus t. X of t whole square, it will become a square cos square omega naught t dt. Okay. So here a square we can write outside the integral. Okay. A square we can write outside. So limit t tends to infinity 1 by 2t cos square theta we can write as 1 plus cos 2 theta by 2. So I am doing that. 1 plus 2 cos omega naught t by 2 and integration minus t2 plus t dt. So in the next step, a square by, I am writing this 2 outside, limit t tends to infinity 1 by 2t integration of 1 t, integration of 1 is t, and integration of cos sine 2 omega naught t divided by 2 omega naught, and the limits we have minus t2 plus t, minus t2 plus t. Let's do upper and lower limits or limits substitution. So a square by 2 limit t tends to infinity 1 by 2t by 2t. Here upper limit is t, lower limit is minus t, minus minus, so it will become 2t plus, here upper limit is t, so sine 2 omega naught t, and what about lower limit? Minus t, lower limit is minus t, so minus, again sine minus, it will become plus sine 2 omega naught t. So sine of 2 omega naught t, sine 2 omega naught t. Okay. It will become 2 sine 2 omega naught t. So I am directly writing this one. So here lower limit is minus t. Upper limit sine 2 omega naught t minus lower limit sine 2 omega naught minus t, sine minus theta minus sine theta, that is why 2 sine 2 omega naught t, right? So divided by 2 omega naught. Okay. Now a square by 2 limit t tends to infinity 1 by 2t. Here we have 2t plus, here we have relation omega naught and time period relation. They are reciprocal. What we know? We know that omega naught is equal to 2 pi f or f naught, and we can write as 2 pi by t naught because f naught is t naught, right? So this point we are going to include. Now it will become 2 sine 2 omega naught. Omega naught is 2 pi by t naught. So 2 pi by t naught. Here we are using t, so 2 pi by t. Okay, t we are using, so 2 pi by t, right? So 2 pi by t. Now sine 2, here again 2 pi by t into t, again divided by, this total is divided by 2 omega naught. Close the bracket. Here t get cancelled. Sine 4 pi. We have sine 4 pi. What is the value of sine 4 pi here? Sine n pi is equal to 0. This is important. Sine pi, sine 2 pi, sine 3 pi, sine 4 pi, 0. So this will become 0. This value is 0. Now what remains? So a square by 2 limit t tends to infinity 1 by 2t 2t. Here 2t get cancelled. So answer is a square by 2. This is the answer. So a cos omega naught t power is a square by 2. Here a is peak amplitude. What is called a? Peak amplitude. Peak amplitude. So to get the power of a cos omega naught t, peak amplitude square by 2. For example, if you have 3 cos omega naught t, what is the power of 3 cos omega naught t? In the place of capital A, we are taking 3 now. So the power is now how much? Power will become 3 square by 2, 9 by 2. Okay. In the same way, another problem. For example, if you have x of t like a cos omega naught t plus b sin omega naught t. What is the average power of this? What is the average power? For a cos omega naught t, just now we have done. What is the average power? A square by 2. Similarly, b sin omega naught t, the average power is b square by 2. So plus is as usual. This is the average power of a cos omega naught t plus b sin omega naught t. And one more important relation. The relation between power and RMS value of the signal. Very, very important. Relation between power and RMS value. And RMS value. Root means square value. RMS means RMS value. S means square. Here R is mean. Sorry, M means mean. R means root. Root means square. Okay. So first mean square value we know already. What is mean square value? 1 by 2t minus t to t mod x of t whole square dt. This is mean square value. Okay, square, and we are doing integration and dividing by duration. Duration minus t2 plus t, it is mean square. Root, if you keep root for this will become RMS. This will become RMS value. Understand? So now the problem is, example, if x of t is equal to a cos 2 pi by 3 t. What is the RMS value of this a cos 2 pi by 3 t? What is the RMS value of a cos 2 pi by 3 t? So first we calculate power. Already we know power is peak amplitude square by 2, that is a square by 2. Then RMS value is equal to, you take just root power. This will become, what it will become? Root a square by 2. So square and root we can write as RMS value is equal to a by root 2. A by root 2. So if you know power calculation, we can do RMS value also. Root mean square value also we can do. Next we are going to see another classification. Causal and non-causal signals. Causal and non-causal signals. A simple definition. Take the continuous time signal x of t. It will become causal. How it is causal? If x of t is equal to 0 for t less than 0. So t less than 0 means left side. So left side, the signal should be 0. The signal should be 0. See the example. The step signal e of t. Unit step function. So t less than 0, it is 0, right or not? Right? So it is causal. Another example. Suppose I am taking triangular function or triangle signal. It is 0 to 4. This is 2. This is x of t. Any signal. Left side t less than 0 means this is t less than 0. There is no signal. X of t is 0. So causal. Right? Now anti-causal. Anti-causal means completely opposite to causal. Anti-causal. That means completely right side the signal is 0. This is anti-causal signal. Now 0 here. For example -3. So this is right side t greater than 0. What is x of t value? 0. The given signal value 0. Right side there is no signal, only completely left side. That is anti-causal. Right? Similarly, if you take the discrete time signal, the same definition, x of n is 0 for n less than 0. For n less than 0, then it will become causal. Okay, for discrete time signal. Non-causal. What is meant by non-causal? How is the non-causal signal? Non-causal signal. So example I am giving, continuous time signal I am taking. This is the non-causal signal. It is available both sides, left side and right side. -3 to +3. Non-causal. The signal is defined both sides, left and right. That is non-causal. For example, another example. This is also non-causal. It is also left side available, right side available. It is also non-causal. So that means x of t is not equal to 0 for t less than 0 and t greater than 0. So it is not equal to 0. It is there. T less than 0 for t greater than 0. Then non-causal. Okay. Similarly, discrete time signal also. X of n is not equal to 0 for n less than 0 and n greater than 0. Both sides the signal is present. That is the meaning of non-causal signal. Now one point is, I will tell you, if you multiply by unit step function u of t, if you multiply by u of t, then the result, suppose I am taking x of t and a signal and multiplying by u of t, x of t into u of t, that is the point I am telling. The result will be causal signal, because u of t, it is available only right side. So x of t is multiplied by u of t, the result is causal signal. The result is causal signal you get. This is the point, remember. And next thing, deterministic and random signals. This is the last classification. Deterministic and random signals. Random signals. Deterministic signal means, suppose if the signal is completely represented by mathematical expression, if the signal is able to completely represent, or if the signal is completely represented by mathematical expression, then it will be called as deterministic signal, because we are able to represent it mathematically. The signal is completely represented by mathematically or mathematical expression, then we can call deterministic signal. Random signal means not able to represent mathematical expression or not able to write using mathematical expression, that is random signal. Okay, it takes random values. It takes random values. Okay, it takes random values, that is random signal. The example for random signal is noise signal, thermal noise. It is generated from resistors, okay, which is the random nature, random values. We cannot represent it mathematically. That is noise signal, random signal, not able to represent mathematically. Deterministic signal means we can represent it mathematically. That is deterministic signal. Okay. So this is a classification. Okay. Thank you students.